Welcome back to Microsoft Build. We are here on the live stage, and I'm super excited to be here with Daniel. How you doing, bud?
Doing right. How about yourself?
Fantastic. So why don't you tell us who you are and what you do? And this is going to be a fun one. Tell us about it.
Oh, it's going to be great. So my name is Daniel Rosenwasser. I'm the product manager on the TypeScript team. I've been there for a long time. I started out as a developer, moved into the PM space because I just kept talking, and they were like, all right, let's move them over here.
Nice.
Yeah. But yeah, so I've been working on TypeScript. So that is the language, the compiler, the editor experience that you know and love in VS and VS Code. And also, if you're just doing JavaScript in these editors, like we're supporting all of that stuff. It's all powered by the same guts that we've been working on for a long time now.
So I remember talking to Anders about, I don't know, it was a year ago or so, about a major change. But before we get to that, I realized, why don't you tell people what TypeScript is, the blurb? Sure. It's super cool. I use it all the time.
Yeah. So basically, you know, many years ago, we found that there was like just this continuous problem for a lot of developers building out big JavaScript apps, right? All of us need to have websites, all of us need to have apps that are cross-platform, that are accessible in the browser sometimes. And so as we sort of needed to do scalability and like actually create more complex apps, we found that there were a lot of other things that we were sort of missing from our other languages, like in C#, like you know that certain things are just plain not going to work.
Yeah.
Not just from like when you compile it, but like as you're typing it in the editor, you're getting a little red squiggle, right? The same way that in Word, you get something that tells you, hey, you might have made a mistake here, a typo. And so we knew that there was a great opportunity for great, solid safety and developer tooling that we could give people. And also, at the time, we were able to bring people modern JavaScript constructs that were still not really available in every browser and runtime. And so TypeScript was a way to take JavaScript and add syntax for types and add a type checker and a compiler so that you could bring all the modern features that you know and love today. And the cool part is, when I first started on that effort, right? I mean, I wasn't there from the very beginning, but I was there from early days. Yeah. And it was like, this is ambitious, right? This is Microsoft. Yeah. We're trying to do an open source project that is in the JS space, the JavaScript space. And a lot of people were like, I don't know. Even before I joined Microsoft, I was like very skeptical about that effort. And then I joined, and then I found out that really the team behind all of it is really passionate and had a very good sensibility of like working with the community and really trying to have a good sense of developer tooling. And so
it's been nice.
Yeah, it has been nice. So nowadays, I mean, I don't know if you caught this on the GitHub Octoverse this past year, but TypeScript actually became the #1 programming language on GitHub. Yeah. And so, you know, if you like beyond JavaScript, right? And so that is kind of nuts. If you had asked me that back then, I would have just laughed you out of the room completely. But now the thing is that's interesting is that TypeScript is now the #1 way for people to build JavaScript apps, period, right? Like we don't really think of these things as so distinct anymore. It's not like TypeScript versus JavaScript. It's I'm doing JavaScript development and I'm using TypeScript, and that's just kind of the core experience. So yeah. I don't know. I mean,
I think it's awesome. Like I use it all the time. In particularly large JavaScript projects, having type safety at the compiler level is super nice. Transpilation layer.
Yeah.
So about a year ago, there was a major shift.
Yes.
From because TypeScript was built on TypeScript, kind of TypeScript on TypeScript, but there was a major shift that happened. Tell us about that.
Right, so TypeScript has been built in TypeScript for over 10 years now, right? It's kind of this food process.
It's 10 years already?
Oh, over that, yeah. And it's like, you know, people call it dog fooding, right? Like you eat your own dog food so you know how good or bad your dog food tastes, or bootstrapping. Basically, by us doing that, that gave us a really solid sense of like what the experience is day to day. But the problem with TypeScript being built in TypeScript is it ultimately compiles down to JavaScript.
Yeah.
JavaScript has had a miraculous amount of development on all the engines, like in V8 and SpiderMonkey and all that. People have made it really fast for the dynamic, you know, interpreted language that people kind of knew from like 1995.
Right.
But, you know, ultimately there's an overhead, right? There's always going to be a little bit more that your engine needs to do. And so there was this sort of gap between what JavaScript is able to do and what you're able to do natively on your CPU, right? And JavaScript kind of fundamentally is single-threaded, right?
Yeah.
There's ways to do multi-threaded JavaScript, but then these threads can't really share the same memory without handing it off fully to each other, right?
Yeah.
And we looked into all sorts of solutions to try to make things faster, but we, as TypeScript's kind of been promising on its, delivering on its promise to do complex JavaScript apps, that means that there's a scalability gap, not just in terms of scaling on your team, but scaling on a big code base. And so people complain, like, my build times are slow, I'm waiting for my editor to like actually load up all the code I've got on disk. And so, all right, let's cut to the chase now.
Yeah.
We actually chose to do a rewrite in the last year and a half or so, taking the existing TypeScript code base and porting it over to Go. And in that port, what we found is a typical sort of speed up that you'll find on many code bases is around 10x, right? Which is pretty mind-blowing.
Yeah.
And so part of that speed up comes from that native speed, and part of it comes from shared memory parallelism. So we're able to actually go faster, not just on one core, but across all the cores that you've got. And I've got a little bit of a demo if we want to dive into that.
Yeah, let's do it. So
yeah.
just to recap, effectively, you didn't TypeScript isn't Go. It's
right.
Go is being used to do the transpilation, to do the type checking, to do all the other stuff.
Right, in a sense, like basically all of the code that we had in the TypeScript code base, we took like, we've got different components. We've got a parser, we've got a checker,
Sure.
we've got like an emitter to like do your code gen. And each of those components was ported over to Go code. But at the end of the day, you're still using this to compile TypeScript code, right? It's still reading JavaScript, it's reading TypeScript, and it's emitting JavaScript, and it's giving you the same exact errors that you've had in the past.
And
right?
before we go to demo, because I remember talking to Anders about this. It wasn't like you just like wrote it in Go and wrote new unit tests. You basically took every part piece by piece.
Yes.
And tell us about that process, because it was not like it was a very methodical approach.
Oh, totally, yeah. So this was also back when agents were a little bit more flaky in the reliability and stuff like that. So a lot of people say, like, why didn't you could you have just viported it over, right? And so at the time, definitely at the time, no. But the cool thing that we did was we used agents to actually write infrastructure to automatically port parts of our code base, right? So like the initial stuff was methodically going through the scanner and the parser. So these two early stages. Artisanal
code, yeah.
And so once we did that, we kind of had a sense of the data structures and how all of the code would look and how we wanted the code to look. And that allowed us to say, like, okay, we have a sense of what we want. Can we partially automate this? So we actually had a script that would take a TypeScript file, right? All of our files are kind of uniformly written in a specific style. And we would say, like, oh, when you're going through the parser, rewrite parts of the parser in so-and-so way. And that way, whenever you're missing something, right, like you have portions of your component, you say, oh, well, I'm missing that functionality. That's literally a function that you're copying and pasting between the two code bases. And then you evaluate, is this new function how I want it, like, is it acting the way I want it to act? Sometimes you'll get a compiler error, and it's intentional because it makes you sort of think about, like, how should this act? So you're just sort of like ripping pieces of auto-generated code into the new code base. But the cool part about that is that it's all very deterministic, right? So if something is not right, you can always say, well, this script needs to be amended. I'll actually adjust the output of this thing, and I'll make sure that it's giving me something that is more predictable, ideal, and more idiomatic Go code for the sort of things that we're writing in the new code base.
So did you like use the AST to generate Go code, or was it?
Yeah. We would use the existing TypeScript APIs.
I see.
But we would use a really cool tool called tsmorph, which uses our ASTs and everything like that under the hood. But it's a really nice API, and we would generate Go code out of that. And that really sped up the development process. And we were able to like reuse all of our unit tests and our input-output tests, like our integration tests. And so over the last year and a half, we've been basically minimizing the differences in all of the tests, right? So we've basically been able to get, like, I would say over 95% of the tests ported over. Some of them don't apply anymore, but like that's because there are certain features that we removed as well. But it's kind of incredible how consistent and fast we've been able to move in that process. I don't think we would have been able to make some of the same strides 5 years ago, for example. But it's been incredible because we've got a lot of great users internally and externally who are giving us great feedback, telling us like, hey, you missed a spot, right? But like that was months ago, right? So it's only gotten more and more and more solid in the last few months.
So in general, if someone switches over to the Go under layer, they're not even gonna know other than that, wow, this feels really snappy.
Right, yeah, so that's the funny thing. It's very interesting to sort of demo these sorts of things like, hey, I have a compiler, I have a faster compiler. Isn't that cool, right? And I can show you why there's a little bit more subtlety to that, but yeah, for the most part, most people will not really notice a difference. There is some stuff that we are trying to work on right now, which applies to the APIs. So if you're relying on stuff like the Vue.js editing experience or Angular or Svelte, like there are certain gaps. You'll still be able to get some benefits from this new compiler architecture. And in fact, you'll get like a fully, the story, like the gaps will close over time. Like actually pretty soon, right? We're working with all those DevTool authors. But most projects, I would say, are just like ready to actually start adopting this.
All right, now that we've done the preamble, people have confidence, let's take a look at what you got. Can you, oh, there you go. You knew exactly what I was gonna ask. Let's take a look. What are we looking at here?
So, okay, I'm actually editing the VS Code code base right now. Like this is actually, if you go to like the VS Code repo on GitHub, this is their source code, right? So I'm gonna actually show you what it is to compile their existing code base today. There's a pretty gross command that I've pasted in here because if you try to compile the VS Code codebase with the existing JavaScript compiler or TypeScript compiler, it runs out of memory. So you have to actually modify, you have to pass like certain flags to Node.js just to say like, by the way, I need some more RAM. Or you can use more RAM, it's okay. So what I'll also show you right now is not that, because we're on Unix. Okay, so this is htop. This is sort of like a process monitor.
Right.
What am I doing here? Let's just do this. Right?
Look at us going old school. Okay. I love it.
Yes. So what you'll notice is that I'm currently on like, if you look at core 15, it's kind of hard to see on this screen, but like if I zoom out, core 15 up here is the only one.
Pegged.
Yeah, it's pegged, right? Like basically, this is sort of like the meme of a bunch of people like construction site and everyone's just like watching one guy dig a hole. And they're like,
everyone's supervising.
Yeah, looks good to me, right?
And this is an artifact of basically Node because it's on a spin lock until it has an IO request.
Right, like right now it's just checking actually.
Oh my gosh.
So it's just checking and it's only able to use one core at any given time because it's not able to like dispatch between different files.
Threads.
Right. When you parse, we go one file by one file, and if you say I'm going to import this guy over here, this file over here, then it's like, well, I have to wait for you to finish parsing before I can do anything else, right? So, right, and then it handed it off to Core 28 or something like that.
So not efficient.
Not efficient. Took 97 seconds, in our opinion. 1 minute and 38 seconds real time, according to the system. That's a little bit hard to see, so I'll zoom in.
Okay.
Okay. So, do we have tsgo? Okay, we don't have tsgo. So tsgo is the binary that we have in place of tsc, the TypeScript compiler, until we're out of like preview stage, right? So if we do npm install @TypeScript/native preview.
Look at him artisanally typing stuff in. What are you, some kind of animal? What's going on here?
Let's do this globally, actually, because... all right, cool. So now we have tsgo. Great. So what you'll see is 7.0, right? The next TypeScript compiler is actually going to be version 7.0, right? That's what we're... And it's nicknamed tsgo for a lot of people. So if we try to do the same command with tsgo, right? We'll do tsgo... we'll point it to the source directory, extended diagnostics, and then we'll also time it too, right? And then we'll do this. We'll look back at htop. What you'll see is that everything is in use right now, right? All of a sudden, all the cores got saturated at the very beginning.
Whoa.
And then
they're awake.
For a very brief second, you might have seen like we went down to like 4, and then we really saturated again. So what happened there was we parsed all of the files in the VS Code code base. I think it's like 1.5 million lines of code. We checked only across 4 cores because checking is not a perfectly parallel problem. And then when we did emit, that was like, all right, throw in all the cores that you got, right? And that made it really fast. So you didn't see it in the background, but that was like 9 seconds or just 10 seconds. We went from like 1.5 minutes to 10 seconds. Non-incremental build, full build, and what I also want to show you as well is that is just the command line experience. So for a lot of people, that's like, well, that's cool. You only have a command line compiler. What else do you got? Well, we have a native preview extension. If you literally go to the marketplace and you type in native preview, TypeScript's native preview is the first thing that comes up, right? And so it says, hey, this workspace, in VS Code, they're already type checking with a new thing, right?
So as you're doing that, why don't you tell us who's using this already?
VS Code, Sentry, Slack, Notion, Figma. Like, we've actually been working with a lot of big companies internally and, well, teams internally and in companies externally, because they know that the quality bar has already been like, it's there for them, right? And they're using it in production, and they've got like much faster turnaround times for their CI. We worked with one team at Microsoft that told us that we were saving them 400 CI hours a month. And so like, maybe in cost, that's like, hey, that's pretty good. But in terms of developer costs, that's great. In terms of like, I'm waiting for an agent to do a thing for me, that's really sweet also.
All right, so we got about a minute left. What do you want to show us in the last minute you got?
I want to show you that basically, let's disable the native preview. If I open up a TS file, you will sometimes see this little spinner here, right? That initializing TS config, all that, right? This is the existing TypeScript experience, and basically what's happening is it's doing that thing where it's going file by file and not able to load it all. I want you to say goodbye to that.
Let's say goodbye.
Let's say goodbye. So this thing, it's automatically enabled when you install. As soon as I open this, I can restart the language server over and over again, and it's just speedy, right? Uh-oh, you didn't see that.
No.
Anyways, it's fast.
Yeah. Hey, we're still working on code. It's okay.
Look, I mean, there are some rough edges. Of course, during a demo, it had to happen that way. But basically, as soon as you open this thing up, I mean, it's still running at this point.
All right.
Yeah.
This is amazing. Like, all I know is that, like, this is really cool. I'm excited to use it. Thank you so much for spending some time with us, bud.
Thanks so much. Yeah.
All right.
Go try it.
We'll be back
it's
after
available
this.
for y'all now.